All right, we can get started for today. I would say up to this point, everything we've learned kind of gives you the base that you really need to be able to run a lot of queries, pull data at a data warehouse. This week and next week will be sort of extra stuff in a way. You can get away with not needing to know these things and still write queries and pull data out. But as soon as you start dealing with sort of larger data sets that you can't really work with in Excel and you need to manipulate more in your SQL, that's when you'll start to be needing to use subqueries and potentially segments and things. And if you're doing stuff for international, then wildcards can come into play and make your job a lot easier. So we'll start with subqueries. So subquery is just a query that's been nested inside of another query. There's multiple names for them. Sometimes they're called inline views and things like that, but I think subquery is nice and intuitive. You basically you write a query, you wrap it in parentheses, and then you put it in another query as if it were a table. So, and then the way the order of operations is the subquery runs first, and then the results of that subquery get stored in a temporary table, and then the outer query then uses that temporary table as if it is a table, and uses that in the outer query. So we'll go into examples that hopefully make this make more sense. And only the columns in the select clause of the subquery will be available to the outer query. Again, that'll make more sense in a minute. So we'll start with just a really silly example. It's not really a logical sort of business case, but hopefully it helps just kind of get the idea of the structure of using a subquery. So we'll start with a query that's totally valid. We're selecting the warehouse ID and calling it FCID from the D warehouses table, and only where the region ID equals 4. So we're going to then wrap that in parentheses. It's worth noting that we drop any semicolon. You only have one semicolon in a SQL statement, and it's at the very end. So if you're using subqueries, you drop that off. Wrap it in parentheses, and then quickly, the results of this subquery, it's only one line. So basically, this query runs and creates a table that looks like that. It's got one column. That column's called FCID because we aliased warehouse ID to FCID, and it has one result in it. And so we can then add a table alias, just like we would if this was just a table itself. And then we can use it like a table in another query. So select from table A, and we can select FCID from table A because that is the name of the column that's in that table. And that's a subquery. And it's just kind of like a table called A with one column called FCID. Oh, so yeah, so that's and then you would put your semicolon here, which I clearly forgot to do. But so that's the very, very basic structure of it. It's a little silly because we're not getting anything unique, no unique value from this outer query. But the next example we go into will sort of show how sometimes you need that subquery to get your data in the way you need it before you then join to something else. So it's a little small. I apologize for that. So this the kind of blue text area here, that's our subquery. And it's pulling from this D promotion order transactions table, pulling customer ID and promo ID, and then how many, it's a count of order IDs, the minimum order day, the minimum order day concatenated with the order ID. We'll just sort of ignore those. Those are overly complex. It's a where clause. Has a where clause here limiting the specific dates, specific promotions, specific region and marketplace. And then we're grouping by customer ID and promo ID and order day. Oh, that's odd. Oh, no, it's not. Well, yeah, anyway. I pulled this query off of BI metadata business questions this morning, so I didn't write it myself. So I'm learning as we go. So basically, this subquery runs. It's going to give us results by customer ID and promo ID. And then we put it inside this other query where we're pulling data out of de-unified customer order items, and then we're joining to the results of this subquery on any time the customer ID is equal to the customer ID in this the subquery table. And then some where clause conditions there. So that subquery runs first and producing the aggregated results. And then the results are stored in the temporary space and joined to the table dunified customer order items on customer ID. And so to sort of think about it, it's as if there is a table in Data Warehouse called promo ID now, and we're just joining that table to that table on that. It's just sort of to simplify what's actually going on. That and that are kind of the same thing. All right. And now the reason we need a subquery here is because in this outer query, we want to evaluate, we only want to return results where the order day in unified customer order items is greater than or equal to the first order day returned by this. And so we need to first figure out what the first order day is, which we do by running a min function. So we're doing an aggregate function to get a value that we need then to evaluate the result of that. And thus we need to run that subquery first in order to figure out what that aggregated value is. And something else to mention is, which I sort of said, but it's sort of what I run into people commonly making this mistake. So I wanted to be super explicit about it. You'll notice in the outer query, anytime it references anything from the promo table, it's referencing what that column is called in the results. So, for example, first promo amount is the alias of this whole big thing. And promo orders is the alias of the count of distinct order ID. The outer query can only see what's in the select clause of the subquery because that subquery runs, it's like a table now. So the select clause defines what the column headers are of of that temporary table. All right. And then kind of the flip side of that, what we can't do, even though depromotion order transactions has marketplace ID in it, because marketplace ID isn't in the select clause, this query is unaware of that column. You can't stick promo marketplace ID in here because it doesn't know that it exists, because it's not going to be in that temporary table that the subquery creates. All right. Yeah, I got this from BI Metadata. Somebody else created it. Just wanted to showcase that it's a very useful place to find sample queries, especially if all of us keep putting sample queries in it as we learn new things and master new data spaces. So, all right, so this is something a little more complex. We're going to sort of this segues into talking about granularity or primary keys a little bit. So we'll have this sort of weird business question. How many copies of Halloween Nation were ordered and shipped each day of the week beginning 9/18? Oh, that should be 2011. Excuse me. I threw this together this morning in the US. All right. So we'll start with, okay, how many units were ordered? Because we want both ordered and shipped. So we'll write a query for ordered because ordered units and shipped units are in different tables. So we'll write a query for that. D-daily orders, region ID 1, marketplace ID 1, defining that activity day window of that 1 week period, limiting it down to the ASIN, and then grouping by activity day, and summing up how many order units. And that's what the results look like. So kind of in the 2 to 7 unit range each day. And then, so sort of forgetting about orders for a minute and talking about shipments, very, very similar query. D-daily shipments instead of D-daily orders. Region ID, activity day, marketplace, like almost identical query, which is nice. And instead of ordered units, we're summing the shipped units. And the results of that are there, again, somewhere between 2 and 7 units per day. Now, obviously, we could run those queries independently and then just VLOOK up the results in Excel because it's a nice small data set, easy to work with. But if it was really big, we might not want to go to that trouble. VLOOKUPs might choke or something. If you're dealing with millions of lines, you wouldn't be able to stick it all in Excel. And so ultimately, we'd like to put this all in a single query to just get the combined results. And so using what we've learned so far, we could do a join between D-daily orders and D-daily shipments anytime the ASIN's equal and the activity days equal. And then kind of put all our where clause conditions from the two queries that we just written, kind of stick them both all together in the same where clause. And then if we run that, we get sort of odd results. So if you remember, all the order units and ship units, we were looking at 2 to 7 units per day. Here we're getting 4 to 42 order units per day and 6 to 21 ship units per day. So something's definitely gone haywire here. And if we compare to our sort of Excel VLOOKUP to results, we can see like these numbers are clearly not wrong. It's definitely overstating both order units and ship units. But why? So the why comes back to this concept of granularity, and you probably heard me talk about one-to-many joins and many-to-many joins and one-to-one joins. And those types of joins, one-to-many joins and many-to-many joins, can result in your sums and counts kind of going a little haywire. And so granularity is this idea of what level is the data stored at in the table, and using my instant data or pulling some sample queries or really studying BI metadata a little bit, you can get an idea of, okay, this is the level the data will be in this table. For example, DMP ASIN's Essentials has data at the ASIN marketplace granularity or grain, because the combination of those two fields will define one unique row. There's other columns, but you'll never find two rows that have the same ASIN marketplace combination. No two records with equivalent values for both those columns. It's also often called a primary key. Another example would be D-distributor order items, and that's the granularity is the order ID ISBN grain. They call ASIN ISBN in that table because it's such an old table. So there's no two records in that table that have the same order ID ISBN combination. So if we think about other tables, D warehouses, the granularity would be warehouse ID. DMP ASIN brand manufacturer, it's another marketplace ID ASIN combination is the kind of primary key in there. D distributor order, did I just use that as the, oh no, that's D distributor order items. D distributor orders, I haven't worked with this table in a few weeks. I actually don't know what the granularity, it would probably be, yeah, I think PO would do it. Yeah, just order ID. Yeah, thank you. All right. So coming back to this question of like how do we get the shipment units and the order units aligned so we're not overcounting them. We kind of need to basically get the results at the same granularity before we join them. Let's see. Oh, okay. I don't know what I was trying to explain here. So I've taken away the aggregation, so we're seeing just the individual lines of that would be returned for just activity day and order units from that table. And I get what I was trying to explain. And so you'll see on 920 there was 2 records. So the granularity is definitely beyond ASIN and activity day. There's some other column that defines that primary key. And so if we kind of start adding some columns, we'll see, oh, okay, we can have different merchant IDs. Like on 920, one of those 2 records for 920 is for merchant customer ID 608808520, which is Amazon.com. The other one is 988123990, which I have no idea what it is. You'll also see sometimes the order method is different. So there's the granularity of this table it's more granular than just day and ASIN. There can be multiple rows in this table for the same day and ASIN. All right, and the same logic kind of holds for D-daily shipments. These tables were built kind of to mirror one another. So similarly, it can have multiple shipments for the same day for the same ASIN for different merchant customer IDs coming out of different warehouses, et cetera. And so if we look at those results side by side and think about, okay, if in our sample query where we just did the straight up join and we got the odd results, this is to kind of help visualize how those odd results came to be. And so we're looking at the raw data out of the two tables where we've got multiple rows for the same day in each. And so when we did that simple join, what Oracle's doing when it's doing the join is it starts with, say, the daily orders table, and starts with the first row that it finds. And then it joins that to any and all rows in the other table that match the join criteria. In this case, we were joining on ASIN and activity day. And so we know these are both filtered down to ASIN. And so essentially it's joining on activity day, and it's finding 7 matches for 918. And so that's what we would think of as a one-to-many join. There's 1 record for 918 in this table. There's 7 records for 918 in that table. So you get a one-to-many join. And so kind of extrapolating that out, if we did that for every line over here and all the lines over there that they match to, another example being 924 here, the last date in the range. There's 3 924s over here, 2 924s over here. So every one of these matches to both of these. So you get this many-to-many situation. And then if we keep marking those out, all of these joins happen. And so basically the 3 units here get multiplied by 7 because it pulls 7 rows from over there. These get sort of double multiplied. It gets very complicated. And so it performs those joins and creates this massive data set before it then aggregates. And that's how we got those sort of multiplied by 7, multiplied by 2, 3, all these different weird numbers that weren't in the 2 to 7 unit range that we were expecting. So when you need to join tables that are of different granularities and you're doing sums or counts or aggregations of any type, generally you'll want to use a subquery so that you can then get the subqueries to produce the data at the same granularity so that then when you do the join, so when you do the join, you're getting a one-to-one match, so you're not going to get a one-to-many or a many-to-many situation that's going to double count sums or counts and things. So we start to do that here. We will wrap both of these in parentheses and give them each an alias. So we'll just call them orders and ships. So those are now subqueries that are going to create 2 temporary tables, one called orders and one called ships, that each have a column called activity day, and then the one has an order units column, the other has a ship units column. I like to indent subqueries because it's easier for me to visualize, so that's totally up to you. Stick a good old semicolon at the end, and then wrap this whole thing in a select from, and define a join. And we'll join where activity day in the resulting table created by this is equal to activity day in the resulting table created by this. And then we can add our use hash hint and start to put some columns in our select. There we go. So now each subquery produces the results like that. And then the results of the subqueries are joined, and there's a one-to-one relationship now. And so we get the expected result of those 2 to 7 units per day of units, order units and ship units. And that matches to what we pulled before. So we know we got it good. All right. Does that, before we move into segments and things, does that all essentially make sense? The idea that subquery is runs first and then it saves the results in a table. I think that's probably the most, to understanding subqueries, that's probably the best way to sort of visualize it or think about it, is that's ignoring the outer query. That's every subquery runs first, and then that gets saved into a temporary table. And then you just think of that result set as if it was a table. Yeah?
In case of joining the subqueries, how do we join? Do we need to look at which subquery is bigger, or from where we're pulling out the most important rows?
That's a really great question. Yeah. So in this example, we've just done an inner join because we kind of actually it probably would have made sense to make it a left join because it's possible that we didn't have shipments on every day, and so actually in theory it could be a full outer join because it's possible that we had shipments on days that we didn't have orders and days that had orders but no shipments. So you can definitely do left joins and right joins if you like right joins better than you like left joins. And it's really to decide sort of which is on the left or right. It's really sort of understanding. Comes back to that irritating. You just have to kind of understand the tables and play around with the results a little bit. The hardest part of what I do is like someone gives me a project and it's new tables that I've never worked with, and I always tell them, like, okay, the hardest part is I'm going to have to spend days just pulling data out of these tables to make sure I understand them so that I don't produce inaccurate results later. So, but yeah, we did an inner join here, but you can do left joins. Here we've got 2 subqueries. You can do 3, 4, lots of subqueries. You can also nest deeper than this. So you can have a subquery inside of a subquery inside of a query. So they act like a table, so you can stick it really anywhere a table would go and use it as you would a table. Does that answer your question? Okay. Yeah, okay, cool. Any other questions about subqueries before we move on to segments? No? Okay.
When working with these,
do
you think we're, especially those of us in the early stages of our development, should create and run the subquery first and then tie it back in?
That's often what I do is like if I'm not familiar with the table or I'm unsure what granularity is going to come back, or like if it's, are these going to join properly? That's often what I'll do is I'll just write the subquery, run the subquery, look at those results, and that'll give me a really great idea of, okay, how should I work with this result set as if it were a table? Yeah, definitely. All right, so segments. So I'm going to assume that probably most of you have worked with segments in maybe DSS. If you haven't, there's definitely a step-by-step of how to create a segment in the training manual and elsewhere I think on Wiki and things. For those of you who haven't worked with them, a segment in Data Warehouse is you kind of create a list of things like ASINs or a list of customer order IDs or a list of vendor codes, and you upload those into Data Warehouse and it saves them in a table, and then you can use that list you can use that table that now has your unique list of ASINs or your unique list of values. And they can be used in DSS queries. Anybody that's used DSS with these knows that you kind of go to a special folder, and then you find the folder with your name, and then you find, I think, the month, and then you find that segment that you created, and you can drag it in as a filter. But you can also use them in ETL queries because behind the scenes what it's doing is adding rows to a table with all of your, say you have 100 ASINs that you create a segment with. It's going to create 100 rows in an existing table, one for each of those ASINs, and then it's going to put your segment ID as another column in that table so that you can join to that table, you can search that table for your segment ID and find just your ASINs. And so, if you're not familiar with segments, if I've lost you a little bit at this point, definitely check out the training manual if you haven't already, and just create a segment, even if you don't need to, just as practice maybe. All right. So I mentioned the segment table. So every type of segment has its own table. So there's one for postal codes. There's one for ISBNs specifically. There's one for purchase orders. There's one for, I think this is customer IDs. This is the customer segment. Lots of them. The one that I use the most and the one that we're going to use for the examples today, if I'm not mistaken, is the product segment membership, which is, it would have been great if it was called ASIN segment membership because it's ASINs. So That's the table that will store any ASIN segment that you've created. Yeah. All right. So once you've created a segment, you create them in the DSS tab. And there's this little segment creator, which you probably can't see from where you're sitting, but right below that is the segment manager, which if you've only used him in DSS, you probably never clicked over there. But if you click on segment manager, it shows you a list of every segment you've ever created since you started working here. And segments never go away. You can't edit segments. If you need to change a segment, you have to create a new segment. And so every single segment you've ever created, these are, I guess the earliest one I built was in 2003. Wow. So what you care about on this page, once your segment's created, it'll get added to the bottom of this list. And what you want to be able to work with your segment in ETL Manager is to grab this segment ID, the first column. And so in this case, 120341 is the segment ID for a segment that I called MSRP fix. That is a product segment, so we know it's a list of ASINs, and apparently has 48 ASINs in it, and I created it in October of 2003 for some reason that I don't remember anymore. All right. So every segment membership table is just a table containing one column with your segment ID and one column with whatever the value is that's in that table, so in this case, ASIN. Plus there's other columns that you don't need to worry about. So if we just did a simple select star, meaning select all the columns from product segment membership where the segment ID is 120341, that segment I created, we get these results. So you see there's segment ID, ASIN, and then some legal entity ID, and then a column called junk that doesn't have anything in it, and I have no idea what that's for. So that's a table that then we can work with just like any other table in Data Warehouse, and it's a table you're empowered to add rows to in a very specific way. So to use that in our SQL, if we take that order ddaily orders query that we were working with before, kind of getting rid of all the subqueries and the joins and all that, just to kind of focus in on segments. So we've got activity day, some of the ordered units from ddaily orders, where we've got region ID and marketplace and activity day conditions in there. We've taken out that ASIN condition that we were using before, because we're going to now use, instead of hard coding in the ASIN, we're going to use our segment to define what ASINs we want to limit the query by. So we're going to do an inner join to that product segment membership table. Excuse me. I need a little water. All right, so we're going to do a join to the product segment membership table. We'll just alias that as PSM. We're going to join on where the ASIN in the ddaily orders table is equal to the ASIN in the product segment membership table. And then we're going to say in our where clause, only return results where the segment ID is our segment that we just created, or that I created a long time ago. Oh, and then we'll update our use hash int because we added a table. All right, so then we get the results there that for the ASINs in that segment, that's how many units were ordered on each of those days in that time range. So it's just like any other table, join to it just like you would any other table, but it's a table you can add rows to. And I'm going to just pause from the PowerPoint for just a second. So sometimes our business question is, how many things were ordered that weren't the ASINs in this segment? So maybe I've got like an exclusion list, and I care about everything except that. So in that case, we would do a left join. We would move this and PSM segment ID condition. We'd move it into the join clause. Let's see if I can grab this. I think this is worth walking through really quickly. Ooh. That's just terrible. All right. Bear with me. Okay. All right. So if we wanted to see what are all the orders during that time period for any ASIN that's not in this segment, we'll create a left join because we know we want things from ddaily orders that aren't going to find matches in the product segment membership table, because by definition that's what we want to do. Because we're doing a left join, any condition on the table to the right of the left join, we want to move those where clause conditions up into the join condition so that that applies before the join, not after. And then we're going to add a condition to say only return results if the ASIN column in PSM is null. So basically, it joins ddaily orders to product segment membership, does a left join, so we're going to get everything from ddaily orders and only matches from product segment membership. It's going to apply the filters on the ddaily orders table to just give us region 1, marketplace 1, that time range. And then it's going to apply this condition saying, OK, now only give me the results where there's no ASIN in the product segment membership table, thereby giving us everything except those ASINs. So it's a fairly common use case. So I just wanted to quickly walk through it. I'm not going to run it because I don't know how long it would take. So, so jumping back into that. Oh, yeah, definitely.
If you have a segment, you said, so once you build them, they're there forever. And let's say I'm tracking holiday-specific ASINs, and they're my holiday ASIN segment. And instead of having a segment from 2010 to 2011, let's say it's still 2011, and I wanted to add or edit the segment. I don't have to just build a whole new segment, right? I can actually go in and edit. No, I have to build a whole new segment.
Yeah, there's no way to edit an existing segment. There's no way to delete an existing segment. You have to always create a new one. So an irritating use case for that when I first joined the books team, when we first started dealing with textbooks and trying to segment the textbook business off of the trade business, there was no identifier anywhere in Data Warehouse for this is a textbook, this is not a textbook. And so we were maintaining, I believe it was 6 segments, one for each band of textbooks. And every time we wanted to add or remove ASINs from those, we had to create a whole new set of 6 and go back and edit every single query that referenced those. So it's super annoying. I found a funny workaround if anybody ever is in that situation. I found a really strange way to get the most recent segment with a specific name. But I wish you could edit them. It would be useful. Ant?
You mentioned you can create segments with only one column. Is there absolutely no other way to have like multiple columns? What if I want ASIN vendor combinations? No.
The only way to do that would be create a vert and create a table in your vert and maintain that. Yeah, which would also be an option if you have kind of a ever-changing list that you need to always be joining to other tables. That could get you around that limitation of the limitations around segments is. Yeah, the many limitations, but it's a great tool. It has lots of uses, but it also has lots of constraints. So, yeah.
Share these amongst the group?
Yeah, absolutely. That's a really great question. Yeah, the segments are universally available, so anybody can use anybody else's segment. You can only really see your segments that you've created in your segment manager. So you'd have to kind of say, oh, here's the ID for that one that you use. So back in the old days, Belay would send me the new 6 segment IDs because I couldn't see them, and then I would add those to my queries. Yeah, there is a table there's a way you can query to see, okay, show me all the segments created by certain users. So if you end up with a use case like that, let me know. Yeah.
What are the limitations on number of columns or
rows?
Or
I don't know of any limitation on how many records you can create in the segment. So there are sort of line between using maybe like an ASIN in and then like a list in parentheses that we've talked about in the past. That has a limitation, I think, of about 200 entries, and once you go past that, it starts to create odd results. And so that's sort of when you cross that line, that's when you kind of have to start using a segment and creating the segment before you create the query. Any other segment questions? No? Okay. All right, so wildcards. So we've looked at a couple wildcards so far. These ETL-specific wildcards. We looked at the job profile ID when we were creating a publisher, and we made that the name of our text file. We've also, last week, we started using the run date wildcard that plugs in that text string. But there's some other wildcards definitely worth mentioning that utilize information in the job section. So when you set up your job, that third box down in a profile, it uses information you set there and then inputs those values into your SQL. And those are region ID, marketplace ID, legal entity ID, and the freeform wildcard. And the first three, you might notice, correspond to those three partition types that you can select when you're setting up your job. And then the last one is its own thing. We'll talk about that one separately. So when you're setting up your job, you have to select one of three partition types, either legal, marketplace, or region. And then in order to get your job to run, you have to select marketplace, one or more marketplaces, or one or more legals, or one or more regions, depending on which partition you picked. So say we take our handy ddaily orders query here, where we've got this condition on marketplace ID, and we've got it hard-coded as 1. If we, hopefully I didn't screw this up. Let's see. Oh yeah, that's not the best way to. So this is not necessarily a good example, but you can plug that wildcard in, that curly brackets in marketplace ID, and it's going to take the values here and plug them into your query right there, which in this case might cause a problem because I picked 2 marketplaces and I used the equals operator instead of the in operator, which I should have used. But I think we have an example of that too. So, and so depending on which, you're only available to you is one partition type, right? So you have to select one of these. And so there's only one of those 3 wildcards available to you in any given query, which is sort of annoying because many queries require both marketplace and region. So you have to get around that in another way. They'll show you an example query that does that. All right, so then the last wildcard is this freeform wildcard, which is exactly what it says. You could put anything you want in that box. So it's also in the job section. It's right above group, and you can stick numbers, text strings, functions, all sorts of stuff in there, and it just plugs that in anywhere you put that wildcard in your SQL. And so as I was complaining about, the marketplace ID we picked marketplace ID as our partition, so that's the only wildcard available to us. So here I'm going to use the freeform wildcard and put the number 1 in the freeform tag. And now I can put the freeform wildcard as what my region ID is equal to so that I can control both of those with a wildcard. And you could also do, as I said, you can do strings of stuff. You can put a string of ASINs in single quotes with commas between them and plug that in, the freeform wildcard, in the parentheses of an in operator condition. You can also stick any wildcard in your publishers, like email address or in the description fields. They're very, very flexible. So in this case, I've created a job where I put my login in the freeform tag field, and then I have an email publisher set up that's emails freeform wildcard at amazon.com. So when this job runs, it's going to email me. And then if I add a second job to the same profile, I've got it set up to email Larry Chen, and he's in a different marketplace than I am, so it's going to run for China, and instead of emailing me, it's going to email Larry. So I don't have to then create 2 separate profiles, maintain the SQL in 2 places. I can use the same SQL for 2 different reasons. And that's very, very common, sort of that regional, or for every locale you have a different job. And to that, oops, sorry, there we go. So here's an example of that. So you'll see it's one profile. It's lightning deals metrics for every day. And well, I haven't done it yet, but the email will be, it will use the freeform tag wildcard. And so it'll plug that into an email address. And so you'll see I've set marketplace ID and I've set the freeform tag. In this case, I've used the 2-letter code for each country because that's what I want to throw into the, let's just edit it right now. What is that? Of course, I can't remember what the email address is. Report. All right. So if I use that freeform wildcard in the email address, now when it runs this job, it's going to put us-csld-report at amazon.com, and it's going to run for Marketplace 1. When it runs this job for the UK, it's going to run for Marketplace 3 and email uk-csld-report, et cetera, so on and so on. And then I mentioned another way of getting around, get down to the meat here. Is that does, yeah, that does it. So here, Marketplace ID is the partition I picked. And so I've used the Marketplace ID wildcard anytime I'm referencing Marketplace ID. But I also need, because I'm using this for lots of different regions, lots of different marketplaces, I also need some sort of way to selectively pick the region ID. And so what I've done is used a decode, which I think we talk about next week, that translates Marketplace ID into the corresponding region ID. That'll make more sense next week. But
One, like why are some numbers repeated, I guess?
yeah, so that,
Or then we'll go over that next week.
Yeah. It's basically they're little pairs. And so Marketplace 1, I'm translating into region 1. Marketplace 3, I'm translating to region 2. I forgot that we hadn't covered that yet when I had the grand idea to show this query. All right, so I think, and so probably already obvious, but in case it's not, just like with the run date wildcard, your query is only limited by the run date wildcard by the run date if you use the run date wildcard. Same goes for these wildcards. I've got sort of two versions of the same query here. One that's limiting to region ID equals the region ID wildcard. One that's hard-coded to 1. This one, it's going to use whatever region ID is set for that job because it's using the wildcard. That one, there's no wildcard, so it's not going to be impacted by whatever. You could have selected region ID 2, and it's still going to run for region ID 1 because that's what's hard-coded in. So, yeah. Any questions about wildcards or anything else we talked about today? No? All right. Any other questions? Homework? Previous weeks? Nothing? All right. I guess I'm a great teacher. All right. Thanks, everybody.